Morning. Can everyone hear me?
Yeah, I hear you.
Okay, so we will continue with last class. So last class we talked about conjunction disjunction. So that's the relationship of the and or of the two statement. So we will move on with the exclusive or you might know with the XOR. So exclusive or is the relation where the two only one of the two proposition is true. But you can only have one of the two proposition to be true in order for the exclusive or statement to be true, which means they cannot be both true and both false. So when they are both true and both false, the statement will be false. And it will be denoted as the little plus sign with the circle around it. Now to translate the statement with the exclusive or, we normally just use either or, right? So we know that in English there is two type of or. You can have the or where that's inclusive, which you can have either. If we talk about A or B, you can have A happen or B happen. You can have both of them happen, right? That's what normally or mean. Exclusive or is a relation where only one of the two events happen, right? So you can either have A happened or B happened. You cannot have both. You cannot have neither. So let's look at the example in a game. We will change the question just a single person. Let's call it John. So we let P to be the proposition where John is a computer science major, and we let Q to be John is a math major. What would the exclusive or statement of the proposition P and Q gonna be? Okay, so I just say that for the either or, we can use um either or, right, for exclusive or. So we can say John is either a CS major or a math major, right? So the either there implies that um it could only be one or the other, cannot be both. Okay, and I see people have John is CS major or math major. When you say that, if you don't have the word either, just have the or, that could be just the disjunction, right? Inclusive or. Right. So when people say this person is CS major or math major, then it could be this person is CS major or math major, or this person could be double major in CS or math. Right. So to emphasize this is exclusive or, we when we translate that, we normally have the word either there. Okay, this is just something to be aware of, and the difference of the exclusive OR and the disjunction OR. Both condition cannot be both true for the exclusive OR. Is this clear? Okay, then we will move on. For the conditional statement, so again, we have two statements, P and Q. And the conditional statement P, and then you see a right arrow to Q, right? We will read it as imply, right? For the conditional statement P imply Q, is the proposition where you can translate it as if P, then Q. So for this conditional statement P implies Q, this is only false when P is true, but Q is false. Otherwise, it's true. Now, in the conditional statement, we normally call P hypothesis and call Q conclusion. Right, or you can say P is the let's see. Okay, so if you look at the chart here, right, this P implies Q is only false when P is true and Q is false. So if you look at, for example, if I let P to be you pass all three exam, and Q will be you pass this course. So what would the statement P implies Q look like? Okay, so that will be if you passed all three exam, then you will pass this course. Now the will there, I just put it there so so the statement are more sounds better. And okay, so this is saying that if you pass all three exams, you will be able to pass this course, right? So for this then, it's okay if you leave out this then. Okay, now let's check this statement with the truth table here, right? And it should make sense to you. So this statement will be true if a student pass all three exams and the student pass the course. Do we see that? So if they are both true, the statement is true. Right, because the statement here is saying that if you pass all three exams, you will pass the course. So when they both true, that's a scenario when the student do pass all three exams and they passed the course. Now what happened on this scenario when the P is true and Q is false? So this is when the student pass all three exams, but did not pass the course. Can that happen?
No.
No, right? Because on your statement, you just promise that if you pass all three exams, you should pass a course. So if the student do pass all 3 exams, you expect them to pass a course. So if they did not pass the course, but they pass all 3 exams, then you know there's something wrong. So this scenario will make this statement false. Now let's look at when P is false. So when a student didn't meet the condition where they pass all 3 exams, then what can happen? So you can have a student did not pass all 3 exams, but still pass the course. Is that possible? Yes, right? Because I just tell you, if you do pass all 3 exams, you will definitely pass the course. But notice that in the conditional statement, I did not mention what if you did not pass all 3 exams. So of course, anything could happen, right? So for the student who did not pass all 3 exams, they could pass the exam or they might fail. They might pass the course or they might fail the course. So when P is false, anything could happen for Q while the statement being true. Right? Since the implication, right, P implies Q, did not tell you what happened if your hypothesis is wrong. Right? It only guarantee you if P is true, then Q must be true. So if P is false, Q could be anything, then it's out of control. Right? Because a student might fail the first exam and study very hard and get a good grade on the remaining 2 exams and pass a course. Or a student might keep doing bad and then fail the course. So that's why for the conditional statement, it's only false when a student meet the hypothesis, but the conclusion is still false. Because this will contradict the conditional statement. Do we see that? Any questions here? Okay, so we just did this one. Now there are many other ways you can express the conditional statement. Right. So the common one is you see the if-then statement. So whenever you see the if-then statement, you know that's the conditional statement. Or you can have if P and Q, right? So if P, Q, right? So for example, you have if you pass all 3 exams, you will pass this course. So you don't need to have the then. And you can have P is sufficient for Q. So in order for Q to happen, you need to have P. Right, so this means like if P happened, Q will happen. Now if P did not happen, then you don't know about the Q. Now you can also have Q happen if P happened. And P happened when Q happened, and a necessary condition for P is Q. And Q unless not P, and we can have just P implies Q. P only if Q. a sufficient condition for Q is P, and then Q whenever Q is necessary for P, or Q follows from P, Q provide that P. Right? So there are different ways to translate the conditional statement. But the most common one you will see is the if P, then Q, if P, Q, or you can have P implies Q. So these three are the most common one. So I'm just have this chart here, so you know, so you know how you can translate it, or if you need it as a reference. Now, giving you a conditional statement, P implies Q, there are many things you can do with it. So you can have converse of the conditional statement, where you just flip the position of P and Q. Right, so if you just switch the position for P and Q, this is called the converse of P implies Q. Or you can not only flip them, you can also negate them. So you have not Q implies not P. That will be the contrapositive of P implies Q. So for contrapositive, not only you switch the position for P and Q, you also negate P and Q. Now, if you just negate P and Q without switch the position, you have not P implies not Q. That will be the inverse of P implies Q. Right. So for example, if you use the example we have for the exam, right? If you pass all 3 exams, you will pass this course. Now, what's the converse of this statement? What's converse of this statement? Okay, I see people have, you will pass this course if you pass all 3 exams. Is that true? So if you have, you will pass this course if you pass all 3 exams, you still have your hypothesis, which your if statement on you pass all 3 exams. So what you did there, it's actually the same as P implies Q. You did not change anything, you just switched the order. Right, so that's just another way to express P implies Q. If you look at the chart, what you are doing is this, right? Q if P. This is still representing P implies Q. Do we see that? So you can just switch the position, right? Because the if part tell you P is the hypothesis, and then you have the Q, which is the conclusion. So to switch the position, you need to make Q your hypothesis. So you are saying that if you pass this course, you must pass all 3 exams. Right, so this student must have passed all 3 exams. So this is saying that if you pass this course, you must pass all 3 exams. Okay. Now, what about the contrapositive? What about the contrapositive mean? You have not Q implies not P. I see people say, if you pass this course, you pass all 3 exams. Doesn't sound right because, I think that's just because of the 10, right? So if you're saying that, if you pass this course, then you must have passed all 3 exams. Then it will make sense. Okay, so I see people have, you will not pass this course if you do not pass all 3 exams. And I see people have, if you didn't pass all 3 exams, you will not pass this course. If you did not pass this course, you did not pass all 3 exams. Okay, so which of these? So I see 3 answers so far. Let's vote here. Which of the 3 answers here are correct? So the first one is saying that if you did not pass this course, you did not pass all 3 exams. Right, so you are negating the Q, which you have if you did not pass this course, right? Because Q means pass this course. So to negating it means you did not pass this course. Then this will implies that you did not pass all 3 exams. Right, because you did not pass all 3 exams, that's the negation of P. So this will be the correct answer, right? So if you say you will not pass this course if you did not pass all 3 exams, that's actually a translation of the inverse of P implies Q. Because your hypothesis, right, your if part is the negation of P. So let me also write it down. You will not pass this course if you do not pass all 3 exams. Right, so this is actually a translation of the inverse statement. Not P implies not Q, because not P is you need to negate the statement you will pass all 3 exams. So you have if you do not pass all 3 exams. So you have the if statement here. Right, so wherever that associate with the hypothesis with the if, that's your P. It's not the position of where you translate it. Right, because P means the hypothesis or the condition, and then Q is the conclusion, right? And then you will negate the conclusion, not Q. So you will pass this course, you will not pass this course. As you have, if you didn't pass all 3 exams, you will not pass this course. So that's the same thing. That's also a translation of the inverse statement, right? Where you just put it in the right order. You have, if you do not pass all 3 exams first, and then you do not pass this course second. So just different order of having this inverse statement. Any questions here? Now, which of the 3 statements here have the same meaning with the implication? Okay, I see people say last 2. So if you say last 2, that means you are saying these 3 statements are talk about the same thing. Okay, and I see people say only the control positive, or I see people say only the inverse. Okay, so let's check one at a time. So so our statement is saying that if you pass all 3 exams, you will pass this course. And again, keep in mind that for the conditional statement, you will only know if you pass all 3 exams, you must pass the course. Which means if you did not pass all 3 exams, anything could happen. That will not contradict this statement. Okay, so the only time this statement is false is when you pass all 3 exams, but you did not pass a course. Okay, so for the contrapositive, is saying that if you did not pass this course, it must mean that you did not pass all 3 exams. Right, because if you and for the inverse, they may say that you will not pass this course if you do not pass all 3 exams. So the inverse statement is saying that, okay, let me make this order. Let me have if part first. Right, so you will not pass if you do not pass all 3 exams, you will not pass this course. So what does it say? If you fail any of the exam, you will not pass the course. Because that's what the statement here is saying. If you do not pass all 3 exams, you will not pass this course. Is that what we said here? In our P implies Q, if you did not pass all 3 exams, can you still pass a course? I see people say yes, right? Because you might pass 2 of the exam, then you still pass with B or C, right? You might still pass maybe with a lower grade, but you will still pass. But if you look at the inverse is saying that if you don't pass all 3 exams, you won't pass a course, which means if you just pass 2 of the exam, you won't pass a course. Right? That's what it says. If you do not pass all 3 exams, you won't pass. Right, so is the inverse the same as the implication? P implies Q? No. Right, and I think the first one's clear. I don't think everyone mentioned the first one, so we know first one is not true. Right, if you pass this course, you must pass all 3 exams. No, people could pass the course with maybe just passing 2 of the exam. Right, so it should be clear that the converse is not the same as the implication. So the only option that's left is the contrapositive. So the contrapositive is saying that if you did not pass this course, then it must mean you did not pass all 3 exams. Right, so if you did not pass a course, you did not pass all 3 exams. Now, what if you do end up pass this course? You don't know. So anything could happen. So for people who pass the course, they could pass with passing all the 3 exams, or maybe they don't pass all 3 exams because you don't know. The statement here only mentioned what happens if you don't pass this course. So if you look at the chart, right? So if you look at the chart here, right? P implies Q is only false when P is true and Q is false. So if we want to check the contrapositive not Q implies not P, right? So we know that when not Q, that won't have not passing the course, it will imply that you must not pass the exam. So if you look at that, when Q is false, right? When we negate the Q, when Q is false, the only condition it can happen is Q is false. Do we see that? When P is false, P must be false in order for this implication to be true. And then if you know the student pass the course, anything could happen. It could be true, it could be false. So if you want me to construct a truth table, so we can have true, 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 false, false, true, false, false. Now we need to have not P. Okay, let me do it with not Q and not P, since we have not Q implies not P. Okay, so for not Q, we will negate this column. So whenever we see a true, we will negate it with false. Whenever we see a false, we will negate it with a true. And then for not P, you will have false, false, true, true. Right, since we are negating the first column, the P. Now with the implication, it's only false when P is true, right? When the hypothesis is true and the condition is false. So we know not P implies not Q is only false when not Q is true and not P is false. So that's here. And all other case will be true. Now, what do we notice? If you compare the truth table, you will see like the truth value of P implies Q and not Q implies not P are the same. Do we see that? But my order of the P and Q are the same. So if you compare this to the truth table for both implication and then the contrapositive of the statement, they are the same. So this means that these two statements are equivalent, right? Are similar. They mean the same thing, right? Because under all these scenarios, their outcome are the same. So contrapositive is equivalent to the implication. Okay, and there's one more thing I want to mention, and that would be the negation of P implies Q. So the negation of P implies Q is actually, you won't get a conditional statement anymore. So the negation, if you're trying to negate P implies Q. So let me actually have the let me get the truth table from here. Okay, so we know to negate a statement, we want to have the truth value that's opposite of this statement. So to negate P implies Q, we will have a truth table of false, true, false, false. Now we know the only time we can make P implies Q false is to have P to be true and Q to be false. Right, since we want to have P to be true and Q to be false to negate it, right? So since we're mentioning the word and, we know it's a conjunction relationship. So we will have P, right? Since we want P to be true and we want Q to be false. So we'll have not Q. And we want both conditions to occur. So it's a conjunction, it's an and relation. Now if you check the, let me actually bring that here. So if you want to check the truth table for P and not Q, right? So we need to have the truth table for not Q, right? Since we don't have it on our list yet, so we'll negate the Q. So we have false, true, false, true, right? We will negate this column. Now we will do a conjunction with P. So P is here, not Q is here. And we know for conjunction, it's only true when both condition is true. So when both P and not Q to be true in order for conjunction to be true. So if you look at it, P is only true on first two row. And then Q is only true on the second row here. So only the second row, P and not Q are both true. So only the second row is true. And then the remaining are all false. Now, if you compare the two, right, negating P and Q is the same as P or not Q, right? Their choose value are the same. So we know the negation of P implies Q is P and not Q. So this means when we have P is true, when we have P is true, it will have not Q, which the same as we have Q, that's false. Any questions here? I see people asking those chart I made for Canvas and others, right? Which chart? The choose table. Okay, so this chart here are for the just for the unconditional statement P implies Q. Now I just want to show you the negation of P implies Q is the same as P or not Q. So I'm using the choose table to show you this choose the negation of P and Q is this. Negation of P and Q is P or P and not Q. No, I don't have the and we did the choose table for control positive because I want to show you the choose table for control positive of P and Q is the same as the choose table for P implies Q. The other two I didn't do, so you can try to do a choose table for Q implies P and not P implies not Q, and you will see that their choose table is not the same. Right, so that's an exercise you could do. Right, so okay, so since we have the table here, so let's just do Q implies P. So I will leave the inverse for you to do. So let's say we want to do Q implies P, right? So this is implication, and we know implication is only false when the hypothesis is true and conclusion is false. So that means when Q is true and when P is false, that will make this statement false. So if you go here to check, when will Q be true and P be false? So when Q be true and when P be false. So that's the third row. So the third row will be false, and then all other condition will be true. Now, when you compare the choose table, they are not the same. Any questions here? Now for the inverse of the statement, so you can negate P and Q. So we already negate the Q, you can also negate the P and then figure out the implication. Okay, so I will leave this one for you to do. Okay, then we'll move on. So this is the last logical proposition operation we will mention here. So again, we have P and Q to be proposition. By condition statement, P if and only if Q, right? You see this double arrow. This will be translated as P if and only if Q. So this biconditional statement is true when P and Q have the same choose value, and it's false otherwise. And biconditional statement is also known as by implication. So if you look at the if and only if statement, is true when they have the same choose value, which means they are either both true or they are both false. Now, if they are different, then if they are different, then the choose value will be false. Now, this is called the by implication because later you will see, or you can prove that this by condition, right, P implies Q, is the same as combining P implies Q and Q implies P. So if we want to translate you pass all three exams, Q will be you pass this course, then the biconditional statement of this P if and only if Q is if you it will be you pass all three exams if and only if you pass this course. Okay, so this actually implies that if you pass all three exams, you will pass a course. If you pass a course, you must pass all three exams. So it goes both ways. So if you fail any of the exam, you will fail the course. Now, if people fail the course, then you can guarantee that this student must fail one of the exam, at least one of the exam. So that's what biconditional statement means. Any questions here? Okay, and a summary of all the operation we did on the propositional logic. Right, so we talk about the negation, right? So to negate a proposition, you pretty much just flip the choose value. And then we talk about the conjunction, where it's only true when both of the statement is true. Now for the disjunction, it's only false when both of them are false. Now we have the exclusive or, where you can either have one of P and Q to be true. So which means they cannot be both true and it cannot be both false. Now for the implication, it's only false if the hypothesis is true and conclusion is false. Right? We spend a lot of time on implication. And for the by condition, or if and only if statement, they will either be both true or both false. So the choose value of one proposition will imply the other one, vice versa. Right? So P is true, Q must be true. If P is false, Q must be false. Other way around too. Okay, and besides, we translate P and Q as P if and only if Q. You can also translate it as P is necessary and sufficient for Q. Or other way around. And also you can have P, if P then Q and conversely. Right, so this means if P and Q and if Q and P. Right, goes both directions. Right, and this IFF is just the same as if and only if. So this will just treat as P if and only if Q. And you can have P exactly when Q happen. So if P happen, Q must happen. In other words, Q did not happen, Q. If P is false, then Q must be false. Right, so again, there's a different way you can express biconditional statement. Okay, so now you see all the operation we can have on the propositional logic. Now you might see more complex proposition, which we call the compound proposition, which means you will see more than one operation at a time. Okay. Now, the order you construct the truth table for the compound proposition, well, it will follow this precedence. I see people say, what does the down arrow mean? This notation here? This is the disjunction. So you can think of it as or.
What did you call it? Disjunction or
This
conjunction?
is and. This is not. Okay, so normally, right, if you see any negation, you will deal with that first, and then you will have and then you can have or. Right, for or, you can either have the disjunction or you can have the exclusive or. And then you will have the implication, and then finally, the biconditional, you will go last. I see people asking, what's the number for? Number is for the precedent, which means which operation should you deal first. So if you see negation, you will deal with that first. I see people asking, what's the difference between or and exclusive or? For the or, we are referring to the inclusive or. Right, so if you look at the chart, let me bring you back to the chart. For the or relation, right, this is the disjunction or. So for disjunction or, you have P or Q. You could either have P is true and Q could be false. You can have Q is true, P is false. So you can have P or Q, or you could have both. You could have P and Q are both true. Now for the exclusive or, you cannot have P and Q both to be true. So exclusive or is like the either or. Only one of the two is true. So you can either have true false or false true. They cannot be both true or both false. And disjunction or is as long as one of the two is true, then it will be true. Now, if you want both of them to be true, that's also fine. So the only difference is this one. Right, the first row. Okay, and again, here's the order. Now, there is one operation that will override all the operator here. That will be the parenthesis. Right? If you see any of the parentheses, then you deal with the parentheses first, right? Like how we do with arithmetic, how we do with the calculation. When you see parentheses, then you forget about the precedence here. You deal with parentheses first. So if we go back, look at this example here, right? We want to construct a truth table. For this compound proposition. So we see two propositional variable here. We see P and Q. So we need to have P and we need to have Q. Right, and then we know we can have them both true. We can have true, false. We can have false, true, and then we can have false, false. So here are the all possible combination you can have for the two variable. Right, true, choose, true, false, false, true, false, false. Okay. Now, if you look at it, we see two parentheses, right? And then in the first parenthesis, you see not Q. So we need to negate the Q. So what's the negation of Q look like? So we'll negate all the value on the Q here. So we'll have false, true, false, true. And then once we have not Q, then we can have P or not Q. Now we know this is or disjunction, and we know disjunction is only false when both condition, when both P and not Q are false. So if you look at P and not Q, the only time they are both false is the third row. So here's false. Anywhere else is true. Okay, so now you take care the left parenthesis. You can take care of the right parenthesis. You will have P and Q. You have conjunction. And then for conjunction, it's true when both of them are true. So you need to find where P and Q are both true, which is the first row. So you have true and they have false, false, false. And then finally, you can have this compound proposition have P or not Q implies P and Q. So for the implication, again, it's only false if you have your hypothesis is true and then your conclusion is false. So you want to find the scenario where the first part is true and then the second part is false. So if you look at the second row, you will have hypothesis is true, conclusion is false. Same thing with the last row. So you will have true. The second row will be false, and you have true, false. Then this is true, and this is false. Any questions here? So this will be the truth table for this compound proposition. Any questions? Now, as an exercise, you can make your own proposition and following the chart to make the truth table of it. Okay, so just like the previous examples, you can just mess up different operation with P and Q, and then construct your own truth table for it, for your compound proposition. Okay, then we will move on. Okay, so now let's look at the bit operation. So you could, so on the bit operation, right? So we know for bits, it will, so for people who have maybe a little CS background, you know, in computer science, we talk about bits a lot, right? Because that's how the computer actually store data. So there's either 0 bits or 1 bit, right? Now, there's actually a corresponding truth value for bit. So normally we would use 1 to represent a statement being true, and we use 0 to represent false. Okay. Now, to better remember which one is which, you can think of if the true value is true, right? For correct answer, you will earn a point. If something is false, you don't get any credit, so it's 0. So we will have 1 for true, 0 for false. Now we can apply the this disjunction, conjunction, and then the XOR, the exclusive OR on the bit operation. So it's the same thing. For the disjunction, it's only false when both variable are false. So it's only you will only get 0 bit when both of them are 0. Now if one of them is 1, then you will get 1. Now for the conjunction, the AND relation is only true if both of the variable is true. So you will only get 1 bit if both of them are 1. Now for the exclusive OR, it's true when X and Y have different truth value. So when you have 0, 1, and 1, 0, it's 1, right? 1 means it's true. Now if they are the same value, then it will be 0. It means it's false. Okay. Now besides bits, you will hear bit string. So bit string, it's a sequence of zeros or 0 or more bits. So which means in this sequence you will see a bunch 0 and 1. All right. So example of bit string is this. So you can have 1 0 1 0 1 0 0 1 1. So this is a bit string of length 9. Right? If you count 1 2 3 4 5 6 7 8 9. Right? So this is a bit string of length 9. Right? I can give you another bit string. You can have bit string of 0 0 1 0 1. And this will be a bit string of length 5. Right. So the bit string, it will just be a sequence of bits. Now let's look at the exercise. So this exercise asks you to find the bitwise OR and XOR of this 2 bit string. So we have 0 1 1 0 1 1 0 1 1 0 and 1 1 0 0 0 1 1 1 0 1. So we want to find the bitwise OR, bitwise AND, and then bitwise XOR. Now we know for the AND operation, for OR, you will only get 0 when you have both of them to be 0. So as long as one of them is 1, then the OR operation will give you 1. So if you look at it, so let's do it from, let's say, right to left. So if you look at it here, 1 0, you have at least 1 1, so the answer is 1. You have 1 0, so that will give you 1. 1 1 will give you 1. 0 1 will give you 1. Okay, you have 1 1 again will give you 1. 1 0 will give you 1. 0 0, which means they both false, so you'll get 0. So for the OR operation, the only time you will get 0 is when they are both 0. So if you have at least 1 1, the result will be 1. Now for AND, if you see any 0, then the result bit will be 0. And you will only get 1 if both of the bits are 1. So you have 1 0, it will be 0. 1 0, it will be 0. 1 1 will be 1. 0 1 will be 0. 1 1 will be 1. 1 0 will be 0. 0 0 will be 0. 1 0 will be 0. 1 1, that will give you 1, and 0 1 will be 0. Any questions here? Okay, now for the XOR, which means it will be 0 if the bits are the same. Now, if the bits are different, then the result bit will be 1. So if you look at 0 1, it will be 1. 1 0 will be 1. 1 1 will be 0, and 0 1 will be 1. They have 1 1, that will be 0. 1 0 will be 1. 0 0 will be 0, and 1 0 will be 1. And then you have 1 1, that will be 0, and then 0 1, that will be 1. Any questions here? Okay, if not, we will end today's class here, since I don't want to move on to a new topic. Okay, so I will say an exercise for you to do. Make your own compound proposition and then construct truth table. So get used to the truth table. Oh, I see people asking where can you see the recording? If you go to the syllabus under the lectures, recordings, and attendance, that section have a link provided there. So you can click on the link and then save the link somewhere. So after class each day, I will post a recording there.
I couldn't find it. Where did you say?
Or later on today, I will maybe I will just copy the link and then put it on the announcement. So you can find it on the announcement section on the Blackboard. Okay, thank you. I see people copying the link in the chat, so you can save that. Any other questions? Okay, then I will see everyone Thursday. Have a nice day.
Bye-bye.
Thank you, Professor.